The sun has been very active over the past few days, emitting several powerful solar flares of class M and X, leading to disruptions in radio communications globally. On May 13, a sunspot named AR 4086 exploded, producing in Zone 2 class solar flare, one of the strongest types. Then, in the early hours of Wednesday, May 14, another sunspot, AR 4087, triggered in 5.3 flare, followed by a much stronger 2.7 flare, and later, in 7.7 flare. The radiation from these solar flares caused radio communication disruptions on the sun-facing side of Earth during their occurrence, affecting areas including North and South America, Europe, Africa, the Middle East, and Southeast Asia. Solar flares are sudden and intense bursts of electromagnetic radiation released from areas with high magnetic activity on the sun's surface, typically within or near sunspots. The sun's surface is covered with powerful magnetic fields, which can become twisted and tangled. When pressure on these lines becomes excessive, they may suddenly break and realign, releasing vast amounts of stored magnetic energy as a solar flare. Some solar flares are much stronger than others. The NOAA Space Weather Prediction Center classifies solar flares into 5 categories: A, B, C, M, and X, with each category being 10 times more powerful than the previous one. Class X flares are the strongest and also the rarest. The number following the letter indicates the exact intensity. For example, an M9 flare is 9 times stronger than an M1 flare. The recent Zone 2 and 2.7 flares fall at the lower end of the most powerful category. The strongest recorded flare in the past 7 years was an X9 flare that occurred in October 2024. According to Space.com, the recent X-class flares are the first of their kind to be recorded since March. Solar flares cause radio communication disruptions because the intense X-ray and ultraviolet radiation emitted affects the Earth's atmosphere. Normally, shortwave radio waves used for long-distance communication are reflected by the ionosphere, allowing them to travel long distances. However, the radiation from solar flares increases the ionization of atoms and molecules in the lower ionosphere, especially in a region known as the D layer. As a result, this layer absorbs radio waves instead of reflecting them, particularly higher frequency waves. X-class solar flares can disrupt radio communications across the illuminated side of the Earth, affecting the activities of mariners, pilots, and even the accuracy of satellite navigation systems. The 2.7 solar flare on Wednesday also triggered a coronal mass ejection, CME, a massive explosion of solar plasma that often occurs simultaneously with solar flares. While flares travel at the speed of light, taking only 8 minutes to reach Earth, CMEs usually travel at speeds between 250 km/s to 3000 km/s, potentially taking several days to arrive. When a CME reaches Earth, its charged particles interact with the atmosphere and the Earth's magnetic field, often creating a geomagnetic storm that can lead to auroras. This phenomenon can also disrupt power grids and impact satellites and GPS systems. Geomagnetic storms are rated from G1 to G5, with the strongest, 5, capable of causing auroras to be seen as far from the poles as the equator. According to the NOAA Space Weather Prediction Center, they can even lead to complete blackouts of power grids. However, due to the position of sunspot AR 4087 at the northeastern edge of the sun, the recent CME event and other potential ejections from recent flares were not directed towards Earth. Instead, they were aimed at Mars. Based on NASA models, the recent CME is expected to reach Mars on Sunday, May 18, and may cause auroras in the planet's atmosphere. In the coming days, sunspot AR 4087 will gradually move across the surface of the sun and align directly with Earth. If this sunspot emits more flare-ups, we may experience radio wave disruptions, and if accompanied by a CME, there is a possibility of geomagnetic storms, which could make auroras visible much farther from the poles. According to the NOAA Space Weather Prediction Center, there is a high probability that at least M-class solar flares will head towards Earth in the next few days.